This is Algebra 3, Unit 7.1, Part 3 of the notes. We're talking about statistics, and we're on the normal distribution, which is a normal bell curve. And we talked about the 68, 95, 99.7 rule, as well as z-scores when we want to find other percentages underneath the curve. Okay, so we did a few quick examples with the standard normal table, which remember has a mean of 0 and a standard deviation of 1. And we're trying to find areas underneath the curve using a standard z table. You can find this table online somewhere, or any statistics textbook has a standard z table. So let's start off with a few examples. Use a standard normal table to find the area underneath the curve for z is less than 1.15. If we go up to the table, remember that the table always gives the area to the left of the curve. And that's on both pages. Okay? So if we want less than, z is less than 1.15. Here's our bell curve. The mean is 0, that's going to be right in the middle. So positive 1.15 is going to be 1.15 standard deviations to the right. And then less than that is going to be the area to the left. So what percentage of the data is in that shaded region? Now we have to go back up to the table and let's find positive 1.15. You can see that on the left here, those are negative. So we've got to be on the right page, and we're going to find 1.1 and then 5. So 1.15 is going to correspond to 0.8749. The area underneath the curve would be 0.8749. As a percentage, that would be 87.49%. Okay, so think about an SAT or a standardized test. 87.49% of the scores would be 1.15 standard deviations and below. Okay? Now let's do part B. Look at the other side of it. This says z-scores greater than 1.15. So my bell curve here, I'm still going to have the mean 0 because it's a standard normal table. And we're going to say 1.15 standard deviations. But now it says greater than, so we're going to shade to the right. The problem is the table doesn't give you shaded to the right. It only gives you to the left. So what we need to do is find the area to the left, which is 0.8749, and then subtract it from 1. So area of this shaded region will be 1 minus 0.8749. And that's going to be 0.1251. If we wanted to make that a percentage, that would be 12.51%. Let's try another one. Let's try E. Z is less than -3. So first things first, draw your bell curve. Mean 0. -3 is going to be 3 standard deviations to the left. So 3 is going to be right here, negative. And we want the area to the left because it's less than. So we want that little piece of shaded area right there. Area of this shaded region. It's to the left, so we can go right to the table and find -3.0. Because it's negative, we'll be on the left side. And you see -3.0, but we have to also decide which column to use, so we want to put -3.00. So we're going to be way to the right there. And that's going to be 0.0013. As a percentage, that would be very small. Move the decimal place over twice. 0.13%. In other words, somebody who is 3 standard deviations away from the mean it's a very unusual data point for a test score or, say, height, something like that. At this point, I'd like you to pause the video and see if you can try parts C, D, F, G, and H. Notice that in H, it's a greater than symbol. So we're going to change that one. Okay, here's what you should have come up with. For part C, this is going to be greater than, so 1 minus 0.9332. So the answer, 0.0668. Part D, it's right at the mean, so that's going to be half. Part F is going to be 0.1587. Part G is going to be 1 minus 0.0228, which is 0.9772. And part H is going to be 1 minus 0.1056, and that's 0.8944. That is all for today. Please be sure to comment on this video in order to earn credit, and then have a nice day.